So this is an example of simulation of the reception of the GPS signals by a rocket. So I have downloaded these 3D models from the Trimble SketchUp library. So I have selected the 3D models. Thanks to the converters provided in the delivery package, you will be able to convert the 3D models into the appropriate proprietary file format, and it's very easy. It takes less than 1 minute, and then you will be able, of course, to import it in SE-NAV. So I would like to show you 3 different simulations. So first of all, the creation of 3D mask. So in that case, there is no satellites, no terrestrial beacons. It's only a computation of the geometrical mask due to the objects surrounding the virtual position of the receiver. So let's select a location, and we just have to display selection of the location. For instance, there, and I just want to add an offset in Z, and then display the mask. So I just have checked on display diagram. So this is a loss mask. I mean, no interaction have been taken into account in this computation. So all in the sphere indicates a mask due, for instance, to the rocket or the launch pad. So of course we can add interactions such as reflections. Let's assume a maximum number of reflections of 2 reflections, and let's update the display. So in that case, you have different color. So in yellow, it means that the incoming rays are both loss and end-loss. So direct pass and reflected pass. In red, you have only loss rays. In green, you have only end-loss. So only reflected rays can reach the receiver, which is located at the center of this virtual sphere. So the only reflected rays can reach the receiver from this incoming direction. So as I told you during our discussion, it's possible to export this data into LMM files and to import it directly in SimGen. So that's the first type of simulation I would like to show you. Let's switch to the second type. So let's display. So the second simulation I would like to carry out is a static simulation. So so there is no diagram anymore. So the principle of the purpose of simulation is to compute the reception, a static reception of GPS. I put the receiver on the top of the rocket. So you can see here the location of the receiver, and then I have selected the GPS constellation. So I have just imported an almanac file, and so I would like to start the simulation. So this is a static simulation. The receiver will remain still during the whole simulation. So SE-NAV will compute a point every 200 seconds, and the simulation lasts 100 hours. So let's start. So in white you have direct rays, and in red you have reflected rays. So as you can see, it's displaying real time till the end of the simulation. Let's add diffractions. So diffractions are displayed in blue. Here you have the sky view. You can select the satellites. Of course, you have a replay mode to display what has been previously computed during the simulation. And as I told you, it's possible to connect it by SimGen in order to provide SimGen with all the information needed to consider multipass during assessment of the receiver performance. It's also possible to use terrestrial beacons instead of using satellites. So I have defined three beacons. They are located at the top of the three towers. So let's see what an example of simulation. So all the beacons emit at the same time, at the same direction. But it's also possible, let's switch off the simulation, it's also possible to define a cycling mode. So in that case, you have a cycle, you can add a latency between two emissions, and of course you can define an emission duration for each beacon. So you may define the cycle. It's possible to model complex simulation. And to conclude, I would like to show you that, of course, it's obviously possible to define a simulation with a moving receiver. So instead of using a static trajectory, you can choose a moving trajectory. So not only one point, simulation point, but several simulation points. So in that case, I have to switch the simulation mode to moving, the sampling time to 1 second, and then I start the simulation. So it computes. So of course you can define the acceleration, the speed, and the jerk of the receiver. So, and all the data that have been computed are recorded in MATLAB format, so that it can be post-processed by an external tool. So that's all for the simulations I wanted to show you.